right, let's do another example of the simple harmonic motion. So I have on a frictionless horizontal air track, I have a glider oscillating from one end of an ideal spring with a force constant of 2.5 newtons per centimeter. The graph to the right here shows the acceleration of the glider as a function of time. And they want me to find the mass of the glider, the amplitude it goes, and the maximum force it experiences. Okay, so let's pull up that graph here quick. All right, and so we see that if I go and look at the maximum acceleration, I see that the maximum acceleration is 12. So the acceleration maximum there is 12, and it is in meters per second squared. And then if I look and try and figure out the period from that graph, I see that the period is 0.2 seconds. Some good place to look at that. You can go from the peak to the peak, and you see that it is 0.2 seconds apart there. All right, let's head back to the board. All right. So I've marked down that the acceleration maximum is 12 meters per second squared and the period is 0.2 seconds. So let's see if we can use this information to find that mass. Okay, so at any point, the maximum acceleration is going to be equal to omega squared times the amplitude. So if I find that maximum acceleration and I know the period, I should be able to find that amplitude. Also, if I add up the forces acting on it and set it equal to ma, there's that mass I'm looking for. And so if I think about a force from a spring, it's going to be k, and let's pick this point that we're talking about here. The maximum displacement, so my force will be ka instead of kx, is equal to m times a max. So looking at this specific point, I should be able to kind of put this all together. And so I end up with k times a divided by a max equals m. Now if I substitute in a max here, I get ka divided by omega squared times a, and so I do see that those a's cancel out for me, and so I don't actually need to know that a value yet. I easily could calculate it here, but I don't need to know it yet. So for part A, I just need to do the spring constant, which I did convert over to newtons per meter, divided by my omega squared. My omega is going to be 2 pi divided by the period, which was 0.2. So plugging in 2500 divided by 2 pi divided by 0.2 quantity squared gives me a mass of 79.58 kilograms. So this is a large mass bouncing around on there. Okay, and that's simply because this is a 2500 Newton meter spring, so it can handle bouncing that around. Part B wants me to find that amplitude, so that's where I'm just going to go ahead and do this step here. So I have 12 divided by omega squared will tell me my amplitude, so that'll be how I find part B. And so I can do 12 divided by 2 pi divided by 0.2 quantity squared. This gives me an amplitude value of 1.2 over pi. Nice work, Mr. Foster. Let's type that in a calculator and get a value here. 1.2 divided by pi, I get 0.38 meters. Part C wants me to find the maximum force it experiences, so that's basically our Ka value here. So all I need to do then is take my 2500 times that 0.38. That will tell me my maximum force, which is K times A. Plugging that in, I end up with a maximum force of 955 newtons for the maximum force exerted there. We will pick up a little bit later on this cool little relationship that omega squared is going to be K over M. And that's going to be true for all springs in simple harmonic motion. And so we're just kind of getting a little taste of it right there. Okay.